Now we're going to want to convert from rectangular coordinates to polar coordinates. But there's a reason why we're showing you this after the other conversion is because, well, this way is a little bit more tricky or a little bit more complicated. Can you understand why? Because remember, every point modeled with our xy's, it could have multiple points in polar coordinates. So we need to be aware of that as we work through these problems. So let's take an example where I have the point -1 and √3 in xy coordinates. So the first thing that we want to do with this process is, as always, or as many times as we can, let's go ahead and plot that point in xy world. So -1, let's make it big points over here. So let's plot it back -1 and up √3. So there I have my point, -1, √3. Then, and I'm going to go ahead and because I know I'm going to polar coordinates, I'm going to put that in there. And I'm going to want to find out this angle at some particular point in time. Okay, I want to be aware that it's in the second quadrant. So the next thing I want to do is find its radius. And I have my radius was x squared plus y squared equals r squared. And so r equals the square root of x squared plus y squared. Let's just work that down. X is a -1, so -1 squared plus √3 squared equals square root of 1 plus 3 equals the square root of 4 equals a 2. So I have a radius of 2, 1 and 2. And now let's figure out what its theta is. The tangent of theta equals y over x. So tangent of theta equals my y coordinate over x, which equals -√3. I know that the tangent of pi thirds equals √3. That's the tangent over in this direction. However, I have a tangent that's in the second quadrant, so I need to figure out what its second quadrant angle is, which is where my -3 is located at. And so that is, I'll have to take the full pi minus pi thirds. Work that out. So what is that? 6. Oh, no. It's 3 over 3. 3/3 pi minus pi thirds. That equals 2/3 pi. And so there's my angle right there. 2/3 pi. And now I have the second part of my radians, or I have the second part of my polar coordinates. My radius is 2. My angle is 2/3 pi. And that's only one representation in polar coordinates. Remember that I can also manipulate it by changing the radius to a negative and adding a multiple of pi plus a 2 pi to its angle, or I can add a multiple of 2 pi to its angle if I keep its radius as positive. Boy, I said a lot of stuff there, and a lot of that stuff probably didn't make sense because we haven't practiced some of the problems yet. So just back up, disregard that part. And for now, understand that we can go from rectangular coordinates to polar coordinates. It's just a little bit more complicated. The first step that you want to do is plot the point in xy world. The second step you want to do is find its radius, and you can use this relationship right here. And then the third step you want to do is recognize which quadrant it's in, so you can find out its smallest positive radius, or sorry, its smallest positive angle to represent the theta.